The miracle of flight. Imagine standing at an airport watching a massive airplane take off into the sky. How does something so heavy defy gravity and soar effortlessly? For centuries, humans dreamed of flying, inspired by birds and the mysteries of the sky. Today, air travel is a routine part of life, connecting distant parts of the world in mere hours. But behind every smooth takeoff and landing lies an intricate dance of physics, engineering, and aerodynamics. In this video, we'll uncover the fascinating science of flight. How do airplanes generate lift? What forces keep them airborne? And how have technological advancements revolutionized the way we travel through the skies? Buckle up because we're about to take off on a journey through the physics of flight. The four forces of flight. At the core of aviation lies four fundamental forces that work together to keep an airplane in the air. Lift, the upward force that counteracts gravity. Weight, the downward force due to gravity pulling the plane toward Earth. Thrust, the forward force that propels the plane forward. Drag, the resistance force that slows the plane down. For an airplane to take off, lift must be greater than weight, and thrust must overcome drag. These forces constantly interact, creating a delicate balance that allows planes to fly smoothly. But how exactly is lift created? The answer lies in aerodynamics, the way air moves around objects. The science of lift, how airplanes defy gravity. Lift is the key to flight, and it all starts with the airplane's wings. Their unique shape, called an airfoil, is designed to manipulate air pressure and generate an upward force. Here's how it works. As air moves over the curved top of the wing, it speeds up, creating an area of low pressure. Below the wing, air moves more slowly, creating an area of high pressure. This difference in pressure generates lift, pulling the plane upward. This principle is best explained by Bernoulli's principle, which states that as the speed of a fluid like air increases, its pressure decreases. The faster-moving air above the wing reduces pressure, while the slower-moving air below creates more pressure, pushing the wing and the airplane upward. But lift alone isn't enough. Planes also need thrust to push them forward, overcoming drag. That's where engines come in. Engines and thrust, the power behind flight. There are different types of aircraft engines, but the most common in commercial aviation are jet engines. These powerful machines work by sucking in air, compressing it, mixing it with fuel, and igniting the mixture. The explosion creates a powerful jet of exhaust, propelling the plane forward with immense force. This forward motion increases airflow over the wings, enhancing lift and allowing the plane to stay in the air. But airplanes don't just fly straight forever. Pilots use control surfaces to navigate through the sky. How pilots control an airplane? Pilots don't just sit back and let physics do all the work. They use several control surfaces to maneuver the aircraft. Ailerons, located on the wings, these control roll, allowing the plane to tilt left or right. Elevators, found on the tail, these control pitch, adjusting the plane's nose up or down. Rudder, also on the tail, it controls yaw, helping the plane turn left or right. By combining these controls, pilots can execute smooth takeoffs, precise turns, and gentle landings. But flying isn't always smooth. Airplanes must also deal with turbulence. Turbulence, the bumps in the sky. Turbulence is one of the most misunderstood aspects of flight. It occurs when an aircraft encounters unstable air currents, causing sudden movements. There are several causes of turbulence. Thermal turbulence, rising warm air creates small pockets of instability. Mechanical turbulence, wind colliding with mountains or buildings can create disturbances. Clear air turbulence (CAT) occurs at high altitudes where different air masses collide. Although turbulence can be unsettling, modern airplanes are designed to withstand extreme forces, and pilots are trained to navigate through rough air safely. But how has aviation evolved over time? The evolution of air travel. From the first successful flight by the Wright brothers in 1903, air travel has undergone a stunning transformation. 1920s, 1930s, the golden age of aviation with the first commercial airlines taking flight, 1940s. World War II led to advancements in jet engines, paving the way for faster travel. 1950s-1960s, the jet age began, making international flights more accessible. 2000s present, innovations like composite materials, fuel-efficient engines, and supersonic concepts are shaping the future of aviation. Speaking of the future, what's next for flight? The future of aviation, supersonic and electric flight. The next generation of aircraft promises to be faster, greener, and more advanced. Supersonic travel, companies like Boom Supersonic are developing planes that could cut flight times in half, making New York to London trips possible in just 3 hours. Electric planes. Advances in battery technology are leading to electric-powered aircraft, reducing carbon emissions and making air travel more sustainable. Urban air mobility, companies are also developing electric vertical takeoff and landing (eVTOL) aircraft, which could revolutionize city transportation. The sky is no longer the limit. Aviation is heading toward a future of incredible possibilities. Conclusion: the magic of flight, from the principles of aerodynamics to the cutting-edge advancements shaping the future, the science of flight is a remarkable fusion of physics, engineering, and human ingenuity. The next time you board a plane, take a moment to appreciate the forces at play, the delicate balance of lift, thrust, weight, and drag that allows a 200-ton aircraft to soar through the sky. Aviation has transformed our world, connecting people and cultures like never before. And as technology continues to evolve, who knows what the next century of flight will bring. Thank you for joining us on this journey through the physics of flight. If you enjoyed this video, make sure to like, subscribe, and hit the notification bell for more amazing science content. See you in the next adventure.